Miata three-piece wheels again. We're following our 555 design style. Today we'll be starting finally part 3, so I'm excited for that. We have completed part 1, which was our 5 varying designs. They were designs of different structure or approach to strength and low weight. We stress tested all of those, picked the best of those 5. Part 2 was we made 5 versions or variations of that winner from part 1. We stress tested all those and found our best one from there. Part 3 will be further refinement of that particular winner of part 2. So I got a cat here. He's being a nice guy. But we're going to focus a little bit more on aesthetics. So we're going to do a little bit of stress testing. But at this point, I'm pretty comfortable with the structure of our wheel. But we might try to refine out any sort of areas that collect forces a little bit more than others. If we can distribute that force further, then life's good. So, yeah, and that'll be our sort of our continuation of part 3 here. I will try to do a bit more aesthetic stuff, so I want to make the wheels look good. I still don't have the true lip profile yet. I'm not entirely sure. Like our lip shape. I know our internal diameter. I know our bolt circle, and I know our offset and lip spacing. So we should be pretty good. But good morning, by the way. I gotta do this before I start my other job. So yeah, we'll try our best to attain essentially 5 very good looking wheels. I'll get the other computer going here too, because we want to. Let's take a review of our stuff to kind of feel where we're at. I'm learning this design process, this 555 sort of setup. Ah, hello. Welcome to the stream. It's Atliker. I am Canadian. Good guess. Does it come out more when I've just woken up? So yeah, we've kind of been documenting how the process has been going here. We started out just having like a little bit of a checklist to do. So we can actually say that we have completed check part 2 here, and we're going to move on to part 3. I won't be watching anybody else's video on our stream today. I apologize. Yeah, we're busy working today. This is work. Yeah. I'm not interested. No, sorry. Yeah, this is actually work for me. So I don't want to interrupt that with a video right now. Other times I would love to. You know, if you want to come back and hang out with some of our other streams when we play video games and stuff, it'd be great. I would love to watch a video with you then. Let's put. Yeah, there we go. Sweet. So we sort of went through part 1 and part 2, recorded our the weight of our designs, and then our rough structure. We actually had quite a variety of weights in our first one, going from 1,300 grams all the way up to almost 2,400 grams. In our part 2, though, we sort of found a little bit closer of a scale here, and so that means we're just getting closer to refining things. I am just waking up right now. There you go. Got 2 mouses going. So to kind of review where our part 1 and part 2 took us, because this is helping me in my brain. I know you're like, oh, I've already seen this. I watched the other 2 videos, Quinn. Well, it's helping my brain. So part 1, we came across our stress tests. It looked like version 4 was our winner. It was the least, had the least deformation, had the highest strength for the lowest weight. And so we followed that there. This was our radial test. This was our torsional test. In part 2, though, We redid like essentially 5 different versions of that wheel, where I took some of the proportions in some of them and stretched them out. I stretched them both in some designs left and right, and I stretched a couple in depth dimensions. We changed the how big the center was to how small the center was. We flexed that out a bunch. So there's a bunch of different changes here to find which direction was the best to go. Weirdly enough, our first version, our version that was most similar to part 1, actually ended up showing the greatest amount of strength to weight. So we're going to continue with part 2 version 1, and yeah. So we're going to take part 2 version 1, and let's start our part 3 file. I'm going to name this part 3 version 1. So if we specifically look at part 3 version 1 or part 2 version 1, we can see some stresses here. So this is our radial test. And to be honest, there is not a lot of visible collection and deformation on the spokes. Nothing that is concerning or worrying in any way. Obviously there is deformation, that there is some area of the spoke that slightly gets more stress than the other. But it is comparatively to our small pool of results, the one that sees that the least. So what I'd actually like to do is re-stress test this, so that I can sort of look at it a little bit more. So we're gonna do that here. I'm first gonna heck this stuff off. Oh my god! Oh my god! Panic, police! All right. So let's re-stress test this guy. I'll do this up for you guys to take a look at. If you're having trouble seeing it because of my graphics, my apologies. You kind of see it there. There you go. All right. Nicely enough, this is weirdly the one that I actually saved the stress test results on. So I wonder actually, am I able to open that file? Let's find out. Let's dig here. Will it let me? Yeah. Do I get to see the stress test results? I have a feeling I am not. Yeah, sadly it won't show me on here. Okay, well that's alright. So what I'll do is I'll take a couple photos of I'll take a couple more photos of this so you can kind of see what I see, if that makes sense. So let's do that. Just give you a bit of a more detailed view of what's going on. I'm excited to finish this process. I got a bunch of other projects that are coming up. But I feel this is very likely to end up being a real wheel. And yeah, that would be... I just love something coming out of my head and being able to hold it in my hands. There's something magical about that. Quinn, are you a father figure? No, nope, 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 nope. Okay. Oh yeah. Let's do this. File. Save as. Network. We got that network. Give me the network. Stress test simulations. Call this V1 dash R1. Save there. Okay. Paste. Save as. Two. Is there any other places I want to look at? This one doesn't seem so much interesting. Okay. Let's open up our static copy here. Hide these guys. Hide this guy. And we'll show our stress results. I'll share this stuff with you in just a second here. Anyway, I need a second. I need a second computer. Or a second cam. Okay, so actually what I can do, maybe help. Let's do this. Although there's some green in there, so I just don't want to show you what we're doing. That's good. I'm okay with this. It's funny. Okay. Do a print screen of that guy. Paste it in here. It's T1. T2 there. All right, I'm going to share with you what we got going on here. There we go. So just looking at how our wheel stressed out here. This was kind of the back of our wheel, so you didn't get to see that in our early tests but you can see it distributed forces pretty decently. A couple areas concern are areas where there is a buildup of stresses. Well, so we got one here. This is on our radial test, so our spun test. This is the only area that we found that had a buildup of stress. On our torsional one, we had some stress built up on these edges here. So a lot of it comes down to how a lot of the strength actually comes down to how the wheel lug inserts are interacting with our spoke edge. Now this was an edge that I didn't fillet on purpose. So we got to take a look at that, see if we can add some strength in there without adding too much mass or material. So let's dig into that. Let's delete our revolve here. There we go. So basically this fillet here is maybe not quite big enough, if that makes sense. And so if we can make that fillet bigger, we can't, can we? We can do 9, 9.5, 9.25, 9.1, 9.15. 9.1 is kind of where we're at. Might be able to add a bit more meat to that. Now looking further at our drawings here. Why don't the arrow keys work? There we go. I really don't want to fillet that. That's going to be a hard one to get a machine in to cut nice and gentle and smooth. I wonder if we can get away with a chamfer in there. I think one other thing we could do is to maybe think about making this a little bit smaller. Not a lot, just a little bit. I want to probably maybe do more than that. This is probably my own fault because my brain doesn't recognize the change that we made. I don't see it. I'm gonna move this one up a bit. Can we grab that? Can I grab that? Oh. Dorp. A little bit out of that. Yes, I know we're gonna fail some stuff. I get it. I understand. So by making that a little bit smaller, we make the side of the spoke a little bit bigger, if that makes sense. Now this actually doesn't need to exist anymore. I know, we got some errors, we'll fix them up. Okay, what's your problem? I'm trying to fillet this. Ah, We have a missing edge. We'll delete that missing edge then. And this should be 1 millimeter. Okay, we'll delete this fillet altogether. Heck it. Okay, this copy here can heck off. There we go. Now, what are you doing? What's your problem? Where was your edge that you were trying to fillet? It's a non-existent edge. Nobody cares about it. Okay. There you go. Sweet. So why are you being weird in here? What was the deal? We wanted to... Ah, okay. We can make you just the slightest... Can you not? Thanks. There we go. Thorpe. Did it again. 0 to 10. Should be able to fill this guy now. Do 1 mil? Will he do 2 mil? 1.55. 1.5. Yeah, there we go. You know what? I'm gonna ditch that fillet. It's not gonna help us. We can also bring this down a little bit. I don't want to destroy this aggressively. I want to tune it slightly. Okay, let's see if there's some areas we can chunk some weight out of this thing, because I think it just got chunkier. This is where our details are going to come into effect. So we were at 1253. I bet you it's chunkier right now. Evaluate mass. Yeah, we're at 1296. So there's got to be a couple places we can chunk some chunk out of this. Dun, dun. Come on, quit being fucking stupid. There we go. Just tell me more. That sucks. Why do people do that? Why do you do that? Yeah, that sucks. Go. Get out of here. Fucking spam garbage. Okay. A couple places we want to make some weight reduction here is we'll do some right in the booty here. Let's see if we can find a nice way to do this. I think there is a nice way we can do this. we go. Circulate that boy. Now we'll do some cuts. Right there. Taper these in about 10 degrees. Yeah. Actually, no, let's not taper those in. Just to simplify manufacturing. And then we'll actually see if we can put a 5mm fillet on this. Yeah, that way you can just drop a 5mm ball mill in there. You don't have to worry about it. Cool, so that chunk there, evaluate, brought us down. Let's take a look here. We were at 1253. This brought us back down to 1261, so still keeping some low weight here. Oh, good morning. Just pull some weight out of that. I like it. There's actually an area I think we can actually put. How do I word this? I think we can put a hole up here. I know it seems wild, but let's take a look at our drawings here. So our stress boys. We got two sets actually. So if we look at our version 1 here, you can see just the ends of the spokes here. On torsional tests, there is almost not a collection of force there. You'll see a darker blue, or a lighter, like a blue patch rather than a green patch, sort of somewhere in the middle of the spoke here. If we go to our radial test, you actually see them there as well. There's an area of the spoke there that's essentially doing nothing. It is, yeah. So we can sort of make it a bit. We can take some material out of that, and we won't lose anything from that. Weirdly enough, which is kind of scary and strange. I think we can also put. Let's take a look at our stresses again. Let's take that. So we're gonna take part 1. I'm gonna move those into part 3 here, so I can look at those. So if we dig into these guys here, you can actually see in the center of our cup here, we actually have an area where there's lots of strength, quite a bit even. Great question. That's actually a really good question. Thanks for hanging out with us. So what'll happen is if I draw a line, let's see here, if I draw one and I click, it wants to continue drawing infinitely. And I'm like, I just wanted to draw one line, so I'll just hit select and then it stops. That's essentially the purpose of that. Yep. Is the program's trying to be helpful, like, hey man, let's keep drawing together, and you're like, no, I'm ready to move on. And it's like, oh, okay, so you have to like tell it to move on. Yeah. It looks like a weird nervous glitch, but I've done it so many times, I don't notice I do it anymore. I actually don't. It kind of weirded me out. I was like, what are you talking about for a second there? And then I was like, oh yeah. Sweet. So yeah, looking into our stress tests here, you can kind of see that we could maybe put a couple little hools. You could probably put a couple hools in there and be okay with it, with removing that weight there. So I'm gonna try that out. We'll have to stress test it to see how that do and if that's good enough for us. I think I want to dump. So let's put in some little choppies, little chippy choppies. I think I want to put my guys in about yeah. Where is that in regards to? Yeah, that's about right. Okay. Thank you. I appreciate the follow, by the way. That's great. If you are curious about what's going on, I don't know when you tuned in, but we're working on a 3-piece Miata wheel for motorsports purposes. This is part of our 555 design theory. So we do 5 like varying designs of like really wild differences. We stress test all those. From those, we pick a winner. We then build 5 versions of that winner, stress test those again, pick a winner, and now we're on our 3rd set of 5, where we're doing sort of 5 variations of that winner. So each time we're getting a little bit more refined, and eventually, if we can make this a 5, 5, 5, 5, 5, 5, 5, 5, 5, 5. We can make it an infinite number of 5s and keep playing and stress testing. But eventually, we're going to have to come to a machinable result. This 3rd part is the hardest part, because not only do I have to make it look good, but it has to also be strong, and I have to consider how the machine's going to cut it. This current design is cuttable, but it's tricky, and so it would be better if it wasn't tricky to the manufacturer. They would love to have the easiest to cut at the highest strength. So, but I want a great wheel, and so I'm going to push them a little bit. I feel like that's going to be good there. We'll set these guys both for construction purposes. If you have any questions about wheel design or anything like that while you're hanging out, feel free to ask them all. If you were going to send me a random YouTube link unannounced for your first time in the stream, I'm probably going to ignore it. Suck a duck. There we go. I'll make that 3 mil. 4 mil? 4 mil. 4 mil. Circular pattern. There we go. And then I'm going to do something a little bit wilder up here. I'm going to go a little bit too far. We'll go maybe a 5 mil hole on this one. We'll do a circular pattern. This is a bit risque, but we're just doing it in the virtual world, so it don't matter. I'm curious to our grams though. So we're a little bit lighter than we were before. I will fillet these guys. You know what? I don't like that the way those cut through. Okay, I am gonna make these guys a bit smaller. So these guys will be a 2 instead. There we go. We're going to add a fillet to these guys. Actually, we'll add a chamfer. As chamfers are easy to manufacture. We'll give them a 1 mil chamfer. 2 mil? 2 mil. Does the booty do it? Do as the booty do? I actually don't like the back doing that. No, don't like the back doing that. And let's see here. Let's put a fillet in here. Oh my god. 1 mil? We'll skip the fillet on this one. We can play with that in a bit here. So I mean, this is worth throwing into the testing machine to see how it fails or where stress is built again on this one. Yeah, let's give it a go. Okay. Let's try it out. Let's see how life hates life. Life finds a way. Okay, what are we at for weight-wise on this guy? 1251. So we added some meat to the spoke here by making the cutout hole a little bit smaller. Yeah. I almost want these on a different axis than we cut them, weirdly enough. I almost want them coming up like through the face here, in a weird way. But let's give this one a try first before we get too detailed on this, because this might just be a stupid idea to cut those holes. Yep. All right. We'll save this, yeah. Nani? Okay, we're gonna save this as something different. 1A, I guess. That's right. I did adjust the stress one instead of playing with the. That's okay. All right. Let's save this as. We're gonna jump into some stress tests here. So these will take a couple minutes here. Yep, I'm ready for you to connect to the network. There we go. Stress. There we go. I wish I could share the stress test a little bit better. I need a capture card or something to do that. Oh, I gotta close this version. There we go. Go. Yeah, we can take a look. I'll leave this up for you guys to look at here. He's not a pretty design. I'll be honest here. This is not a beautiful wheel. It's an intriguing wheel, but if we really go to look at how it looks pretty yeah. It's not a beautiful wheel. Yeah, it's heckin' ugly. Whew. Oh boy, those extra holes did not improve the look. We're gonna re-stress test this though for sport, just to kind of see if we're chasing the right tail. Gotta chase the right tail. I'll be right back. I'm just gonna grab some water. Oh yeah. Oh yeah. Oh yeah. Okay, let's run that stress test. Sweet. So yeah, our goal here is to try to make this attractive. I mean, essentially our the file that we started with today was strong enough, if that makes sense. We're trying to like maybe tweak that a bit more, but really I should be focusing on the aesthetics of this. So we'll stress test this one, and then I'll move on to maybe making one that I feel is more beautiful, if that makes sense. This is a jobby, so it is not quite either. I have been paid for wheel design in the past. I will be paid for wheel design in the future, but it is something I do because I want to do it and not because people are hounding at my door. Yeah. This failed. Why did this fail? It won't. Let's run. Come on. Okay, we have to relook at our torque here. Yeah, it got confused. Okay, that's no problem. There we go. Yeah, it's something I enjoy doing. I don't know if you've hung out with us in the past. If you have, welcome back. But I can show you kind of some of the other stuff I've done. We have built some rear wheels. It has happened. It doesn't happen often, but it did occur. So we actually, let's see here if I can find the right process here. Well, I guess you can just kind of jump into some rear wheels that we made. These are our V-types. This is a 5-spoke V-type that we made. This is our GSX1 wheel that we made. Some probably better photos, but they too started out as just a 3D concept that we made, and then had machined. And so yeah, we had 4 and 5-spoke versions of both GSX1 and V-types. They actually started from a plastic prototype. So I have a 3D printer here. I just printed a big 3D. This is actually the plastic prototype. Weirdly enough, it's hard to determine or distinguish the two, which is neat. Okay, one of our stress tests is finished. And okay, I can tell you now, our holes did not help. So let me record this. I learned SolidWorks in a different way. I wasn't introduced to it as a mechanical engineer. I was introduced as an artist, and so I kind of learned it on my own, only for creating cool shapes and forms and stuff. And so some of the ways that I'm now adding in the mechanical engineering side of it. So a lot of it was just trying to make the program create like designs and shapes that I thought were cool. It wasn't actually for manufacturing purposes, and now we're kind of stepping that in afterwards. And I don't know. People say I'm good at SolidWorks. I don't know if I am. I don't have comparative. I didn't go to school, so I don't know. Because most other 3D programs I'm really terrible at. I just get yelled at them and throw things. But I kind of like the idea of creating the lid of the can and stretching the lid of the can out. Like that's the way yeah, like you create the lid and you stretch it into a full can. I feel that works better in my brain, which a lot of other 3D programs don't kind of work that way. I also like the idea I can go look at a real object and measure it and tell the thing to measure it, which is cool, which is something that a lot of 3D programs don't really do very well either. And I can go in and fiddle and push. So I can go in and like push the thing like, oh, that's too small. Okay, now it's bigger, and I don't have to redo everything. Okay, let's flex this boy. I have a feeling those holes in the spokes we're gonna ditch. But the holes in the hub, I have a strong feeling we're gonna keep. But I will share our results with you in just a moment here. This is good that we failed at this. You're like, what do you mean that's good? Well, every time you fail at this, you can show somebody that you've tried ideas. Because they'll come back at you with ideas like, what about this? Well, I did that. Here's that thing. Or, I can't think of anything better. Well, these are the things that I did think that might be better, and these are the ones that worked and didn't. Either way, it makes it look good. Yeah, SolidWorks is great. I love it. It's casual, and I can create something really quickly. And then I can just literally hit the print button and it exists in real life. And it's like, whoa, like it translates the idea out of my head the quickest into a real item. So I do really like SolidWorks that way. Oh, this song. Help. Okay. Let's save some of this results and data. Aircraft mechanics very cool, by the way. You gotta get used to paperwork though. Oh my god. Part 331A-1. Taking back. This, we'll save this guy. Also, I have a feeling that you didn't really come to Twitch today thinking you'd run into somebody doing SolidWorks on car wheels. Let's do our nest stress test. Oh, you got confused again. We're on to our second stress test of the two. First one's did. It's a slow process. These streams aren't really for entertainment purposes. We play some video games. We have some good times that way, just like Twitch is supposed to be used. I'm using Twitch sort of, one, to keep company while I work on this stuff. Two, to the big thing is I'm really trying to show our process. So when somebody hands me an idea and says, hey, did you flush this idea out? Did you try all the things? And go like, this is what we did. Maybe that's flushed out to you, maybe it's not. But this is the process we went through. So I'm just documenting the start to finish on one wheel entirely. Okay, that's meshed out. Now we can run that mesh. Actually, I was teaching myself how to use our costings tab the other day. So in SolidWorks, you can actually sort of tell SolidWorks to figure out how much things cost. I don't have it installed in this version of SolidWorks. My other one I do. But you can kind of go through and it'll make a rough idea of, based on the weight of the product, how much machining time it needs to take and stuff. It gives you a really, really rough cost. And then it gives you a final unit price, which is neat. You can be like, I want to make 100 of these. what's it going to cost me per unit per 100? If shop labor time is this, and how many hours is it going to cost to cut this out of this material? And it sort of comes up with a rough, like a decently rough guess, which is kind of cool. I can only assume the sustainability here is a thing as well. This guy's neat, the DFMX guy. I was playing with him as well. And he's sort of, let's say you are trying to machine an item and you're like, can this be done? It kind of gives you a really rough idea of like, yeah, the machine will be able to do that, or no, the machine will not be able to reach that. Sadly, it doesn't actually consider 5-axis mills, which this is what we'll be making this on. So even though the program comes back saying, "Ooh, a lot of this is really hard to cut," we should be okay because it's going on based on just a traditional mill and lathes for the most part. It, for whatever reason, doesn't really have the capabilities at the point to like project 3 or 5-axis milling machines, CNCs. Is it hard to find a company that'll 3D print this? We won't be 3D printing this. This will be machined out of solid aluminum. But if you ever do need something wild like this 3D printed, there's a really good website called 3D Hubs. I've used them before in a couple small projects, but they can do everything from printing in just PLA or like really like ABS plastic, like some of the basic 3D printing, or like FDM printing where they add material, like traditional 3D printers. They also have SLA type printing, so like SLA is like really small fine detail stuff. If you want to build model car wheels, you want to use SLA printing. And then they also have CNC machining stuff as well. And what it is it's not one company doing all this machining for you or this manufacturing. It's actually a network of companies that subscribe to the service. And so it finds the one that's kind of best for whatever you're trying to do, that's closest to you. And so you don't end up negotiating a price with the manufacturer. It's all automatically created. So you don't have to sit there and like negotiate prices over the one prototype that you want to make. You just get a number and you either like the number and you press buy, or you don't, you move on. And I find that's really easy to use. And you can upload the file into their system, and then they figure out how to translate that to the manufacturer for you. So it's sort of like Amazon for manufacturing. Like you just click the buy button, you don't have to do any thinking. It's really nice. So if you are going to hunt, some of the prices can be wild though, so just be careful. That's why I have my own 3D printer. I got sick of paying other people to print for me, so I was like, nope. And I bought a printer. I saved up all my pennies. Okay, finish. Stress testing. Really taking a long time here. It's gonna take a bit. Yeah, I'm gonna ditch these holes. Almost guaranteed. For some reason, I find this little crest here very beautiful. Just that little whoop whoop. I really like that. It's not helpful in any way, but I think it's wonderful. Okay. The results are in. Let's take a look. Oh, you do your thing. You struggle and get angry. That's what you do. that is interesting. Our adjustments to specifically our cut through hole or cut through spoke actually didn't make it any stronger. So I added meat to the area where it was had stress, and it actually didn't improve the strength of it. So that goes to show you that more metal isn't always better metal. I'll show you these results in a second here. Let's take a look here. That's interesting. Right. Now I'm going to share some of our spoke results here so you can kind of see why it wasn't better. You chump. There you go. Almost did. We're getting there. The tension is killing me. It's killing me. There we go. Alright. So I'll open this up here for you so you can take a seat. So this is with our current changes and adjustments. You okay, buddy? Come in and lay down. Make sure the cat's happy. And yeah, you can see we've actually increased deformation by adding those holes there. Our radial test doesn't look too aggressively different. You'll see our radial test was actually stronger before when we had bigger holes in there, weirdly enough. That's wild. And our torsional test doesn't seem too different, although we've essentially weakened the spoke on purpose to try to distribute stresses a little bit better. But here's where it got. You can see in the back of the spoke here, even though we made we made the sides of this thicker, it actually collected more force there. So that actually wasn't an improvement. So we can kind of go to say here that yeah, that wasn't a way of improving strength for this wheel. So we're going to ditch all that and try again. There you go. Part 3, version 2. So we're back to this guy here. So yeah, this is the hardest part of the process. It is most difficult. Thing too. Yeah, let's hide you. I don't need to see you. You can see our brake clearance chart here is our green. Our pink is the lips that we're running.
Seeing all the reasons we should forget about this place, but I don't want to leave here if you're just gonna stay. Changing like the seasons, been wasting all this time. Should be like satellites, cast me on the sky.
Why doesn't it like that?
Another day, riding these horizons, we'll find a way.
See if we go really extreme, if it'll take it. Sometimes it's the case.
Just follow me to paradise. Just say we try. Say the word and we can run around the earth and around the sun. Say the word and we can stay. Forget about that dirty maze. And I know you're healing, 'cause I know the feeling. The streets stop breathing.
Well, if you can do your math in SolidWorks, then you might be ahead. Okay, let's delete that. Let's see how the computer hates this. It hates it. Yeah, we can fix that up. Don't worry. Don't panic. That edge is right here, actually. We can make this pretty big. Yeah, you can do it, little computer. You can process that. Okay. Our next one here is this guy. And he thought his edge was missing, but it was here all along. Oh, yeah, 5? 2? 3? 2.5? I get 2 mil out of it, at least now. Okay. How does that look comparatively? Hey, you know what? Thanks. There you go. I don't think I made a change or improvement. Nope. Start again. Cat. Come on. There you go, buddy. Let's see here. So let's do some weight savings. Let's take the weight of this thing. Let's trim this boy. How far can we push it? 15? 12.5. There we go. And then fillet the snot out of these things. So we'll do a 5 mil. There we go. And then for sport, we'll even chamfer this guy. We'll do him 0.1 of an inch. Go. That should take a bunch of the meat out of the area that's doing nothing. Let's evaluate him. Mass properties. He has 1,200 grams. Let's put some focus and aesthetic here. I don't feel I am smart enough to really, without more time, I've got to do some more work today. I don't feel like I'm smart enough to really be able to take much more out of this without sacrificing a lot of strength and having to redo a bunch of this work. Okay, cat. See you later. Weirdo. Okay, let's do a thing. So let's create a plane here, unless I already have a plane. Plane 2 is visible. It can heck off. What do I got for planes here? Plane 1. Plane 1's not going to do for us. Okay, we're going to have to create a new plane. That's okay. Can do it. Yep. Somewhere out here is great. Okay. I'm going to sketch on this. Let's go to construction. Oh, yeah. Hmm. 8? No. 16? Yeah, 16 will do for us. See ya. Go. We'll do a circular pattern on this, guys. There we are. Go. Or what this is gonna be like. Let's try this out. Hey, thanks for hanging out, by the way. Come hang out with us while we play some video games. We do a lot of car stuff. But I appreciate you hanging out today. And have a good day. And study that, get the MATLAB done. Okay, we're going to offset from the surface. This is our surface here. Yeah. We're going to do it 1 minute. Maybe it's having troubles that way. Doesn't like the surface, huh? Give me a second here. we go. Alright, this font sucks. Let's change it. Okay, I can figure that out. That's no problem. So what if it does extruded cut? It's doing that extruded cut, but we're going to offset it from the surface. We're going to offset it 1. We're going to reverse offset. There we go. Ta-dung. That would make sense. Yeah, grumpy. Struggling here. Struggling. Can't. There we go. Nearly impossible to cut, but that's okay. Yeah, I'm having fun with this. Okay. How do I make this this? I'm struggling on this one. We might only get 1 or 2 done today, which is okay. Man, I don't know, man. Brain block, frustrate, crunch. Born. Okay, we're gonna save this here. Actually, what I'd like to do is put these drill holes in. Cut. All. What are we at for mass here? 1178, huh? Okay. I wish that you were here with me. Save. This song, awful. I mean, God. Ish. There you go. Oh. Dorp. Five. There you go. Okay, we got our lips here. They're ugly. Let me tell you what. Oh. And let's do it. Let us do the wild thing. If we go into our hardware, forget the diameter here. This is 10.8. Okay. All right, clean, yeah. Go. This guy here will be for construction. He and he will be parallel. You will be mid-pointed here. You'll be construction as well, but your length will be 10.8. Like, whoa, Quinn, weird. And then do a roll. Do a revolve cut. This. Go. But we're gonna clone that. So get a pattern. This. here, so access will be... Ah. Go. Now we can do a circular pattern of 2 around axis 1. And now we should have those cuts in there. We do. New file, save as. We'll use those foreman barrels. Boop. Hey, Jazzbug, welcome. Good to see you. Welcome back. We're not doing a super exciting stream today. I'm actually just sort of documenting some work, and you get to hang out with me if you want to while I document some work. Normally we'll play some racing or car games, but today we are doing this week and last week we've been working on this design project. So you're welcome to hang out. If you got more car questions, always ask them. That's what I like to do, is answer car questions. Sweet. Okay, so we've got that figured out. We got this guy figured out. And we got this guy figured out. So let's start doing a thing. File, new assembly. Let's assemble. Autobots, assemble. Okay, let's do this. Put a center in there. Let's hide all those drawings because they're just going to look busy. We're going to insert a new component. And it's going to be our foreman barrels. We're going to take this boop and we're going to tell, hey man, I need you to mate up with this boop. And it's like, no problem. I did it. Cool. You are not required in any way to have any questions, but yeah. We're making a 3-piece Miata wheel. So it's a motorsport wheel, specifically for like track racing. And I'm doing it for a customer. Yeah, and we've been working on this for, I would say, a good week now. Yeah. Playing around. This one's a unique one because we actually have cuts through the spokes, through the very center of the spoke, almost to create them tubular. So yeah, you can kind of see how things going. Thank you. Yeah, we've been doing FEA, or finite element analysis on it. We've been basically taking it and stress testing it like you would in the real world, just as a simulation, to make a guess to see how and where it's going to fail. Insert some more components here. Let's do this. Right now, we're on to the part of the project, so it's a 3-part project. We're on to the part of the project where we're just worrying about how it looks now. We've sort of got to where we're comfortable with how strong it is. But yeah, we're now trying to make it look good. Problem is that sometimes it's difficult to balance function and form, or strength and beauty. Sometimes it's difficult to balance those two. The two, if balanced, are exceptionally much better. And so, I don't know if I'm doing a good job of balancing the two, but I know it's going to be pretty lightweight, and hopefully decently strong. Finite element analysis is really just a guess. Yeah, you shoot. Hit me with all your questions. I'd love to answer them all. So let's create a circular component. We're going to components pattern. We're going to do 4. I'm going to go around this circle. That'll do. There you go. Airless tires have been around for a long time. Basically, they are a version of foam. So if you were to blow bubbles into your milk and you built foam, those are essentially trapped bubbles of air. And they, I mean, if it wasn't made of the tension of the milk, like the meniscus or surface tension of the fluid of the milk, then it could be actually much stronger. If you made it out of a rubber or a polymer or something like that, that essentially that foam would be stronger. In the sense of a closed cell foam, closed cell is when the bubble is completely encased. It's a full bubble. A balloon if you blew up a balloon, it would be a closed cell bubble. But open cell bubbles are ones that are truly airless. So a closed cell, it will trap air in it. Like a pontoon boat is a closed cell. It's got air trapped in it. A tire itself is a closed cell. But you can do that in a much micro sense. So let's say I have a balloon filled with 100 small balloons. I'm sure you've seen that at like a balloon shop, a balloon filled with balloons. That's kind of what foam is, weirdly enough. It's just balloons trapped within balloons. But open cell foam is when you were to take a balloon and cut the ends off it. Now the air can pass through, but in a traditional balloon, it would just collapse. If you were to make the structure of the balloon much stiffer and maybe thicker rubber, then it would be an open cell. It could support the weight of it could support weight without having the ends closed or having the air to distribute the load over. So airless tires have been around for a long time. There's a couple different styles. There are closed cell foam ones. A lot of dirt bikes or professional motocross riders use that. They put foam inserts instead of filling the tire up, so that when a nail comes through and punctures it, it doesn't let out all the air. It only lets out maybe 3 bubbles of the 10 million bubbles that you have. There's other types though. Michelin and I guess a couple of the tire companies have been playing around with them with open cell ones. Basically, they take, let's say you took a hockey puck and you drilled a hole in the center of the hockey puck, and then you took 50 of those, or maybe 1,500 of those hockey pucks and assembled them in a tire shape. That would hold the car off the ground, and it would not need air to do that. The hockey puck is strong enough to do so. So that's kind of what the type of airless tire you're probably thinking of, I'm guessing. That was a long explanation for a question I just could have asked. But yeah, airless tires are great, except unless you can adjust. Yeah, it's just essentially replacing air with the strength of a tire. What's funny is modern car tires are considered what are called radial tires. It means the belts inside the tire, the cords inside the tire, are organized in a fashion that's called radial. There used to be tires called bias ply tires. Basically, it would be like a cross mesh weave of the little metal rods inside the tires, and they were so stiff that you actually didn't need air in them to keep the car off the ground. But they also weren't very pliable. They didn't grip the road well. So really, we had airless tires for a really long time. It's just that technology and sort of like materials, like carbon fiber and all that stuff, sort of, yeah, off topic. That's okay. We've kind of had airless tires for a long time, but it's never really caught on. The biggest problem with airless tires is really difficult to adjust what you're using them for. For example, if I'm driving my Jeep on the highway, I've got my big lifted off-road Jeep. I want to put a lot of air pressure in those tires because I'm on a very hard surface, and so I don't want the Jeep to slow down. I want it to be able to grip the road well. But if I come up to, let's say, some rocks I want to crawl my Jeep over, I'm going to air those tires down so that when the tire interacts with a rock, it actually can grip around the rock. It's a very soft tire then. And most airless tires can't make that quick adjustment. And that's why they've never really caught on. I can't, like if I'm racing, if I'm Formula One, I might want to run an extra pound of pressure on one track and 1 pound less on another track, depending on how short or how long the course is. And it's really difficult to adjust that in a tire with no adjustments. The air that fills our tires is a really helpful tool for quick adjustments for different uses. So actually, to segue into our design here, we actually have 2 air. I'm gonna put them in. We got 2 valve stems on this particular one because you can use it to purge air, which is nerdy and weird. In a lot of high-end racing applications, they will use nitrogen instead of air to fill their tires. Now, the air that you breathe every day is actually there's really the only adjustment you can adjust is air pressure. And so yeah, that's why a lot of airless tires haven't caught on. There are some applications where an airless tire is amazing. For example, if I am driving my dirt bike through the desert, I don't want air in there because I don't want to lose that air. I don't have any way of adding the air back in if I blow a tire out or anything like that. So yeah, there are some applications where it's perfect, like Paris to Dakar. That's an awesome time to have that. I'm not sure if you're familiar with Paris to Dakar rally, but it is a rally across the desert, and it is extremely difficult. And if you get stuck in the middle of the desert, you get stuck in the middle of the desert. So airless tires in extreme cases are really good, but in most cases they're just, you lose adaptation. Actually, that's really commonly true for a lot of racing stuff. Is you will sacrifice one convenience for another. So, yeah, rally driving is the most, how do I say it? Yeah, if you're bored today and you want to learn a little bit more about rallying, and it specifically to do that topic, like people too close to the cars, you can look up a documentary called Too Fast to Race, and it's free on YouTube. It's a really old documentary from the 1980s, late 80s, early 90s, I should say, and it's great. It documents a very famous rallying sanctioning body called Group B, and the cars, they had to close Group B because a lot of people got hurt. It's it's Group B stuff. Yeah, but Too Fast to Race, and there's even a sequel, Still Too Fast to Race, or something like that. It's very good documentaries. Okay, we're gonna insert some components here. We're almost did. There we go. I want to. Yeah, I want this guy to mate with this guy. I want this guy. This guy to teamwork here. Should work. Where did... Okay. Yeah, okay. That makes sense. There we go. Okay, let's do this. Let's do some rotations here. Yeah, that way. Yeah, Too Fast to Race is a great documentary. This. There we go. A circular component here. 15 of those guys. Essentially, hey, hello, boyfriend. Welcome to the stream. So we've got our Miata wheel here. Dun, dun, dun. This is essentially our first concept visually of our wheels. Yeah, this isn't too bad. Let's do some renders for sport. Do an assembly. E3, E2. There we go. We can do it. Let's do a bronze or a silver. Let's say it. Whew. I gotta learn how to sleep better. Okay, let's do this. Okay. Hit me with all the questions. I love them. At any point, if I don't answer the question like correctly, or you're like, I don't know what he means by that, just call me out and be like, hey, can you like do that again? That's totally okay. I don't mind. That's literally my job every day. Yeah, I want a true silver. There we go. Do I have a preferred racing number? Number 87. It has no obvious significance, but I like it. Okay. Let's see here. We want our stainless steel. Do I want a zinc? Yeah, let's do some zinky boys. Yeah, zinky boys. And then put some old steel to these guys here. There we go. So you guys make 26. Let's get some stainless going on here as well. Yeah. Go, and then we need our miscellaneous, which will have our flat black in there. Do I want a stainless steel on this? No, I don't want a stainless steel on this. Oh, we gotta get the nuts in the back. The back nuts. Don't forget the back nuts. It's this is called Keyshot. This is about rendering, like doing final renders of 3D stuff. I don't use it as aggressively as I should. Some people are a little bit better at tuning things in. I just do it as a quick way of seeing what I like and what I don't like. I think we'll put our aluminum on there. There we go. And we forgot about the nuts. I don't know how I feel about these zinc nuts though. I feel like a brass would look better. If that makes sense. Does a brass look better? I don't know a lot about all the different rims ever made. Some people are a little bit better than I am at it. I'm not 100% sure. You can ask me, like if you post like an Imgur link of a rim, I can try to guess at it. Some of them I know, some of them I don't. So I'm gonna use a steel dusty on those guys. There we go. The rims on the 2018 Porsche RSR. I probably won't know this, I'll be honest. I'll take a look here. This is actually a factory rim. So this is actually built by Porsche. Yeah, these are factory rims from Porsche. So the Porsche G. I'm trying to think. There is a Cayman and a 911 Club that you can buy from Porsche. These are factory. They came that way from Porsche. They make a center lug version and a non-center lug version. Yeah, Club Sport. Yeah, these come factory on that vehicle as well. I'm sure there's probably a smaller company that's hired by Porsche to make them, but they come factory on the Club Sport. Let's take a look here. Yeah, these are a hub pattern or a five lug version, and then they have a center lock version for like full racing builds. But yeah, I used to interact with the GT4 Club Sport all the time. We had one at the track I worked at. Caymans are great. You want a Cayman over a 911, even though all the 911 purists will be like, yeah, I got a 911. No, get the Cayman. Don't waste your time. The Cayman's easier to drive. It's not faster overall, but it's about a thousandth of a second slower, but you'll get there a lot quicker. Hard to explain, but okay. I guess I'm just gonna run with the brass. I'm not a big fan of maybe steel on these guys. Really don't need this timeline. There we go. She's not a beautiful wheel. I'll tell you that. It has to do with brakes. It also has to do with tire manufacturers. So it's a bit of a disconnect. You'll see a lot of time attack people put bigger and bigger wheels on their cars. And it's not because they want bigger wheels on the cars. It's because often the tires that are grippier and usually wider are in larger diameters, which is annoying. But the reason that most tire manufacturers do that is because when you are building race cars and you're stopping from really high speeds, you need big brakes. Big brakes have a better clamping force. So it's essentially like if you consider the center of the wheel, like where it rotates from the center out to the end of the brake disc is like a bar, like you're trying to tighten, a bolt. And so the larger diameter that disc gets, the more clamping force, the more leverage the caliper has. So it's gonna pinch that disc and hold it or slow the car down more. But additionally, the bigger the disc brake is, the more area you have to dissipate heat on. So yeah, it's for about the bigger the brake is, the better it brakes, if that makes sense. So the better it is able to clamp and slow down the wheel, but also dissipate the heat that creates. So yeah, you'll find in Formula One they use different materials. So they use full carbon fiber or carbon ceramic brakes, and those clamp so hard and dissipate heat so well that they actually don't need a big diameter wheel or big diameter brake rotor, and so the wheels are actually small. They're only 14 or 15 inch big wheels. So really, smaller wheels. The smaller the wheel is, essentially the faster the car is going to go, it's basically carrying less weight. But the problem is that you won't be able to fit very big brakes in there. So most racing series, because they can't afford like $30,000 brake systems for their cars, have to run really large wheels. F1's interesting only for the technology. The racing is boring to watch, but the technology that goes into the car and the stuff that happens off the track, stuff that happens in the engineering room, is really cool and fun. Yeah, I think that stuff's pretty neat. But it's not racing, if that makes sense. It is business. So if you're really into cool business stuff, yeah, Formula One's neat. But if you're into racing, Formula One's pretty boring. I don't like our center color. Let's change our color. There you go. Earthy. Open wheel racing is fun to do. So it looks stupid looking in, but it's fun looking out, if that makes sense. So if you're sitting in the cockpit, you feel really close in. You feel very naked in the car. You don't feel like there's a lot of safety around you, which is in some ways exhilarating, if that makes sense. The other thing is you can really pay attention to what the tires are doing. So when you're drifting a car, let's say you have a Nissan 240SX. You got your 240SX, you saved up all your money for an overpriced automobile. and you're drifting. One of the hardest things when you're first drifting is trying to figure out where the front wheels are comparatively to you. You can't see them. When you're in an open wheel car, you can see exactly what the wheels are doing. You can hear them a lot better. You can see the road. You can actually watch how the tire interacts with the road and stuff. And so, even though it looks ugly looking out, like looking as a fan looking in at the open wheel car, from sitting inside the car is the real true experience. So, yeah, just give that a try. You can rent those cars. Okay, this is an ugly wheel. I did not do a good job making this look beautiful. I'll tell you what. We're going to render this. I am running out of steam for this version of the project for right now. I'm going to have to come back another day on this, but we'll do a quick render, a couple quick renders on this, and then we'll continue on in the future. Part 3, version 2. And there we go. So we're going to be doing 5 versions, aesthetic versions of the wheel here. We'll call this our first aesthetic version of the wheel. I'm not stoked on how it looks, and I want to make some changes to make it look a little bit better. Ultimately, we have to sell this stuff, so even though we've made a really light wheel, our lip profile is heinous. Whoo, it's heinous. But it's because we have to run such a small center in this. So this is a 15-inch wheel, but the center of it is only 9 inches. What's more expensive? It depends. Drifting is actually really cheap. So drifting can be done really, really affordably if you are good at driving and don't care about horsepower. The moment you add horsepower to drifting is where it gets really expensive. But you don't end up having more fun that much, if that makes sense. So yeah, to give you a better answer, track days, like racing for time, trying to beat somebody from point A to point B over time, it gets really expensive. The reason being is if you are not in first place, even if you're not a competitive person,
but you are competing, you will want to push further. And for most people, they push the car instead of themselves, so they'll put more money into the car than into learning how to drive it better. Either way, if you're putting money into learning how to drive it better, you're going to do a lot of courses and things like that. So track days can be really expensive. A good example is a local here, actually, who has made it very inexpensive. He bought a bone stock FRS. He put really grippy tires on it, so that was a cost that he had to cover. That was like $700 or $800 cost. And then he runs those at track days and just tries to drive. He tries to drive as hard as he can until the car is not as good as him. So there's two limiting factors when it comes to being really fast. Is you have the driver and you have the car, and the two have to teamwork together. And so you can have an amazing driver, but if the car is no good, then, well, yeah, you're going to have to improve the car to improve the overall. The overall is whatever's lowest. In 99% of cases, though, that think they're amazing at driving, usually the driver is holding them back. The driver is not as good as the car. The only time you really should be upgrading the car is when you are better than the car, if that makes sense. And usually that's not the case. Most people just throw a lot of money at the car because they feel like the car is holding them back when they actually haven't gotten good at driving. But yeah, so you just take one car, a very bone stock car, you put some really grippy tires on it, and you drive it until you can't go faster. And you feel like you are sitting there, you're bored by it. You should be bored by what's happening on the track. That when you are bored, you know you're good at driving and you're going fast. If it's still exciting, or you're scaring yourself, or you feel like hyped by it, then yeah, you're probably going pretty slow. Okay, this render looks nice. That one does look good. There are a couple others here. So, yeah, track days are generally more expensive. Tires in general are just more expensive for track days. Drifting can be really cheap if you follow what's called the balance, the balance between power to grip ratio. So if I have 100 horsepower, I put a small tire on the car. If I have 1,000 horsepower, I put an expensive tire on the car. You can drift fairly competitively, and at a high rate of fun. I would rate it a high rate of fun in a slow car. I want to re-render that because I didn't get it quite in the frame. There we go. You don't need a lot of horsepower to have a really good time drifting. Where sometimes with grip racing, if you are feeling competitive, then yeah, you're gonna have to put more and more into the car. So overall, grip racing is way more expensive on average. There's other things that are relative to you as well, like are you the person that has to pay to get into track days, or do you have like access to a extra thing that other people don't have? Whatever the case may be, anything that makes you, yeah. So some people might find grip racing cheaper. Okay, let's do some back render. Water. Render me up, Captain. There you go. So yeah, we'll end up doing another 4 sort of aesthetic versions of this wheel. This is just our first. Sometimes forcing yourself to work works well, sometimes you don't. Today it's not flowing as well as I'd like it to. I got to do some work teaching some drivers later on today, so... Track Mustang. That's not bad. You can buy those kind of pre-built like that, actually. That car is probably not built at home or by a shop, but rather like a company that just pre-builds those. So there's some nice ones. Actually, Track Mustangs. There's a good Facebook group for Track Mustangs. Weirdly enough, I follow a bunch of weird Facebook groups. So, okay. Dun-da-da. So we got some renders going on here. Let's take a look at our renders. Different generations of Mustangs are better than the others. The newer the Mustang, the better, though. Usually the case would be the other way around. Older cars are better, but Fox body Mustangs were pretty garbage. Like they actually were really bad. They were a very poorly designed car, but they were they were very not internationally loved. You can find actually a bunch of them imported to Australia for drag racing, but they are a car that looks good, but they were really mechanically sad. And you had to do a lot of work to make them enjoyable. 2010, 2014, that's cool. Hey, don't care if it's poopy. That's fair. Donado Trampas, welcome. Oh my God, the cap locks. Donald, you're tuning in just a little bit late. We're about to end our stream here. We're just reviewing sort of some of the stuff that we did today. So we moved on to part 3 of our Miata wheel design stuff. We're now working on the aesthetics of our wheel. We did some stress testing to try to improve the strength of our wheel, if that makes sense. And we found that there wasn't much we could do. So we are starting to work on the visuals of our wheel. These need to be improved a little bit, I'm going to say. But yeah. Off the bed. Yeah, it's coming along. Hey, thanks for hanging out with us, Jazza. Yeah. So yeah, this is kind of where we're at for today. This is going to be the end of our stream here, I think. Poof. Oh, wow. But we are using our hollow spoke design here, where we have a hole cut out for the spoke. Yeah. And actually, you know what we can do before we run away from this? Let's figure out what our wheel weighs. Okay. This one is aluminum. These guys are not aluminum yet. We're going to give them a rough aluminum because I'm not sure which one they're going to be using for this. I will just give them a 6061 for now. Okay, this is steel, yep. Valve stem, stainless, yep. M8, stainless. There we go. Cool, so we've got roughly our materials in there. Let's figure out how chonky this boy is. So we're at 5,017 grams. Let's find out. So he's an 11-pound wheel. All in all, in 15-inch wheel at 11 pounds. Now, I still can't beat the Volk T37. You can't. One-piece wheels, when you get down to this size, will often be lighter. Yeah, what is that? Yeah. I'm trying to think of what is that Miata company? That Miata wheel. I can't remember. Meow. There's that one company that does Miata wheels specifically. 949. What is the weight of their wheels? It's probably lighter than this, to be honest. So this is their 15 by 8 plus 25. 12.6. Ooh. Ooh, 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 ooh. So we're a little bit lighter. Yeah, they've gone pretty ham on getting the right wheel lug nuts and stuff too. That's kind of neat. Part of our weight is just that I put in 2 valve stems. If we were to pull a valve stem into there, it would be a little bit lighter as well. So, ta-da! Cool. That's our guy for now. But okay, I think that's going to be the end of the stream for us today. We're gonna come back to this. We still got more work to do. We're near the end of this project, which is great. But we got more to do here. Yeah, thanks for hanging out, and we'll see you again soon. We'll get back to video games eventually. My apologies. I'm not that sorry. I like working on this stuff, but yeah. Okay. Bye.